Today's lesson is a very simple one, but very critical for algebra. Today we're going to be combining like terms. This is section 2.3, and we're trying to figure out what like terms are and why we have to put them together. There's a couple of definitions we need right up front. The first one is a coefficient. That's a big fancy word for something you probably recognized for something else before. So if we look at just like this term 2x right there, all we're trying to determine is what the coefficient is. Well, the number 2 is the coefficient. So when you see any variable like that, 3y, the 3 is the coefficient. So just a fancy name for the number in front of the variable. And the next term is the constant. If we look at the expression up above, we do have just a 3, that's just a number by itself, and a 4, and that's actually a negative 4. We're subtracting 4. So those two numbers are constant because those are just numbers without variables. To understand combining like terms, we're first going to look at combining shapes. So if you take a look at this field of shapes, we have triangles, squares, circles, and we're adding them. So that means we're combining them. We're putting them together. So if I told you to group the like terms, you would put all those similar shapes together. So I'm going to do this magically right before your eyes. So what I've done here is I just put all the squares together, triangles together, and the circles together. So if I were to ask you how many of each we have, well, you would just say simply, well, we have 5 squares, we have 4 triangles, and 3 circles. So if we were trying to write that, I'm going to bring these up from here just to make it a little simpler. So we have 5 squares, we have 4 triangles, and 3 circles. And of course we are combining these, so I'm just going to steal a little plus sign right here and a plus sign right here. So in combining like terms, simplifying this expression, we'd have 5 squares, 4 triangles, and 3 circles. Now let's just say we're dealing with letters instead of shapes. So these letters, of course, are going to be variables. That's how we're going to connect it to algebra. So let's go ahead and perform a magic act again. Let's put all the B's, A's, and C's together. And voila! So we have, take a look at it. We have a B term, we have A terms, and we have C terms. So how many of each? Well, there's 2 B's, so 2 times B would mean we have 2B right there. We also have 3 A's, and 2 C's. So 2, 3, and 2 are the coefficients. And again, I'm just going to steal a little plus sign from both of these so it looks like we have it. We're combining the like terms right here, 2B, 3A, and 2C. So here's where we're going to combine everything we've learned so far in the video. So let's say we already have a number. We have an x term with 35 as the coefficient and an x term with 15 as the coefficient. So what we can do is combine them because of the addition sign. So let's just look at it in terms of apples. If I told you I had 35 apples and I gave you 15 more apples, well, how many apples would you have? Well, you just add the coefficients and you'd know that you'd have 50 apples. So that's the same thing we're doing with the x terms or the variable terms. Now here's a little different example here because we've actually introduced 2 variables. You see we here have an h term. So you know that h and x are not similar terms. Those are they're different variables. So let's just rewrite this by grouping the similar terms. So we're going to have 12x plus 8x minus 7x plus h. So again, we're going to put this h on hold for just a second because he doesn't belong with the other guys there. So let's just do our order of operations left to right. 12x plus 8x is 20x minus 7x plus h. We can't forget about him. So 20x minus 7x is 13x plus h. So we've got this simplified, and we can't combine the h term and the x term. You can't put apples together with oranges. All right, so we're just going to keep it that way. We have 13 apples and 1 orange. So finally, you knew the distributive property was coming at some point, and that we were going to have to deal with the negative numbers also. So look at my directions up above. It says simplify using distribution first. So we have to distribute first. So there's nothing to distribute here with 5x plus 2. We can multiply 3 times x for the distributive property. 3 times x is 3x, and then we have to multiply 3 times. Now let's just not forget that that's a negative 1, a minus 1. So this term here is going to be a negative 3, or subtracting 3. Now we have to put like terms together. So let's rewrite it like that. We're going to have a 5x term, a 3x term, a 2, and a minus 3. So now let's combine like terms. We have 8x plus, and this is going to be 2 minus 3, so that's going to be a negative 1. Now we can rewrite that simply. If we're adding a negative, it's just like subtracting 8x minus 1. And that would be how you would simplify using distribution. All right, go ahead and start working on your examples right now.